Okay, welcome back for another video lecture on section 1.6 in unit 2. Now section 1.6 talks about solving different types of equations, and I've titled this section rational equations, even though we will talk about square root equations just very briefly here. Now, first thing we need to know is what exactly is a rational equation? A rational equation is any sort of equation that looks like this, where I have a variable in the denominator equal to some other stuff. And there may be more than one variable in the denominator, as you will see in the examples here. But the point is that in each case here, we have a fraction where the variable is in the denominator of the fraction. If the variable is in the numerator of the fraction and it looks complicated, we still handle those like normal linear or quadratic equations. There's no special thing that happens there. But when the variable is in the bottom, we have a very specific procedure we need to follow. Now, solving these things works very much so like it did in Unit 1 if it works out to be linear, or like it did earlier in Unit 2 if it works out to be quadratic. The very first step we need to do on all of these is to note the domain of the equation that we're looking at. In other words, we need to figure out what numbers will cause us to divide by 0. The second thing we're going to do is we're going to clear the fraction, much like we did in Unit 1. And then we're going to do either Unit 1 techniques or Unit 2 techniques to solve. If we get a linear equation, we use Unit 1 techniques. If we get a quadratic equation, we use Unit 2 techniques. So here I have two examples. In example number 1, I have 1 over x is equal to 1 over 5 plus 3 over 2x. And so what I need to do first is always take note of what the domain is. In other words, what numbers am I not allowed to have for x? So I've written down x cannot be equal to, and I'm going to figure out what numbers I could possibly plug in for x that will cause any part of this equation to divide by 0. Well, notice this is 1 over x. If I plug in a 0, that's 1 divided by 0. I'm not allowed to have that. So x cannot be 0. Now, checking the rest of this equation, you can also see that multiplying 0 by 2 has no effect. So this particular part here is the same as this particular part here with respect to what I cannot plug in for x. So I've found the domain. I can't have 0, but I can plug anything else in. The next thing I need to do is I need to clear the fraction. And if you remember, we can do several different things here. I can attempt to find a the least common multiple and multiply by it. Or I can simply try something and then continue to try things until I have no more fractions. So that's my personal favorite method because there's less computation. What I'm going to do is I'm just going to pick one of the denominators, whatever looks to be the most complicated to me. To me, that's 2x. And I'm going to multiply everything by it. Okay, when I multiply 2x through, first I have to multiply 2x by 1 over x. The x's cancel, leaving me with 2. When I multiply 2x by 1/5, I'll have 2x over 5 because nothing cancels. And then when the denominator and the thing I'm multiplying by match, they have the effect of canceling each other, leaving us with the numerator of that term. The second question is, do I still have fractions? And yes, I do, just like we did in Unit 1. At this point, we're going to work this exactly the same as we did in the Unit 1 problem. So I have fractions. I'm going to, again, attempt to clear it by multiplying by just one of the denominators. The only denominator I have here is 5, so I'm going to multiply everything by 5. 2 times 5 gives me 10. 2x over 5 times 5, the denominator and the thing I'm multiplying by match, so that has the effect of canceling, leaving me with just the numerator. And then, of course, 3 times 5 is 15. And at this point, you can see that I have a nice linear expression, and so this should be very, very easy to find. I'm going to subtract 15 from both sides, leaving me with minus 5 equals to 2x. Then I'm going to divide both sides by 2, canceling the 2 off of the right-hand side, giving me that x is equal to negative 5 over 2. Okay. Now, most of you are used to getting to a statement that x is equal to something, and then you type that into your solution set, and that will work in this particular case. But what I need you to be very, very aware of here is that when we're dealing with rational equations or square root equations, there's always one last step and that is check your solution against the domain. Step 5, check your solution against the domain. So that means I'm going to take this proposed solution of mine, and I'm going to look at the little green note that I made for myself earlier. And I'm basically going to ask, is this number that I came up with one of the numbers that I wasn't allowed to have in the first place? And if it is one of the numbers that I'm not allowed to have, then I can't say that that is a solution. So in this case, where I only get one thing, I would just write no solution, because what I got was something that I'm not allowed to have. In the case where we have more than one solution, I'm going to just leave off the ones that I'm not allowed to have. Now in this case, -5/2, it doesn't matter how weird the answer is, it's not 0. So that means that this is in fact my solution to this problem. Rational expressions can, you notice we're using Unit 1 and Unit 2 techniques to solve this. This means that it will turn into either a linear expression or it will turn into a quadratic expression. What I'm going to show you now is one that will turn into a quadratic expression. So here we have, well actually this one may not turn into a quadratic expression. We'll show you one of those in a minute. So in example number 2, what I want to show you here is that sometimes when we get this funny looking quadratic expression on the bottom, a lot of us kind of shut down at this point. We're like, I don't know how to handle that. But you do know how to factor quadratic expressions. So if this is x squared plus 0x minus 25, you would know how to factor this. We can use all the techniques that we discussed during 1.5 or 1.4 to do this. Now, another thing is, if you remember your Algebra 2 really well, we noticed that x squared minus 25 is a difference of 2 squares, which means that I can write it as x minus 5 times x plus 5. And I suggest that you do this anytime you see a rational equation where you have a quadratic term in the bottom. Attempt to factor the quadratic term always. And that's because these particular problems that you're seeing in college algebra, they're designed to be done this way. Sometimes this doesn't work, but the same procedure of multiplying things through will let you come up with an answer eventually. Okay, so step 1, I'm going to note the domain. There are 2 numbers that x cannot be in this case. If you look at this part right here, x plus 5. X plus 5 is shared by this term and this term over here. And if I plug in -5, that'll be -5 plus 5, which is 0, and that will say 4 divided by 0, which I'm not allowed to have. So I cannot plug in -5. Now x minus 5 is shared by this term and this term, and if I plug in +5, it's the same effect. We'll divide by 0, which we're not allowed to have. So the 2 numbers I'm not allowed to have are -5 and +5. Now notice that I didn't just immediately say, oh, x can't be 0. I'm looking for numbers that make me divide by 0, not asking whether I plug in 0 into the denominator. Because notice if I plug 0 into this denominator, I get +5. That's 4 divided by 5. I can do that. We don't like to do that, but I can. If I plug in 0 here, that's 2 divided by -5. Again, I can do that. If I plug 0 in here, that's 32 divided by -25. We really don't like to do that, but I can do it if I have to. So the 2 numbers I'm not allowed to have are -5 and +5. Step 2, I'm going to try to clear the fraction. So clearing the fraction, I'm going to multiply by whatever the most complicated looking, need to move this a little bit, whatever the most complicated looking denominator happens to be. Here, that's x minus 5 times x plus 5, because we can all agree that this denominator is more complicated than either of those 2. This is really nice though, because when I multiply this term through, the parts of the denominator that match the parts of the thing I'm multiplying by, they will cancel each other, leaving me with only the part that didn't match times the numerator. So notice, this denominator times 4 over x plus 5, the x plus 5s will cancel, leaving me with 4 times x minus 5 plus. In the second term, the x minus 5s cancel, leaving me with 2 times x plus 5. And on the right-hand side, since this denominator is identically that term, the whole thing will cancel, leaving me with 32. At this point, I have a linear equation, and so I'm going to distribute and combine solve the same way we did in Unit 1. Distributing 4 through x minus 5, we get 4x minus 20 plus, distributing 2 through x plus 5, we get 2x plus 10 equals 32. I can combine my like terms here. We notice that 4x and 2x are common to each other, and minus 20 and positive 10 are common to each other. In other words, I've got terms that have just an x, and I've got constant terms that I can add and subtract together. So 4x plus 2x, which is 6x, minus 20 plus 10, which is minus 10, and then I have 32 right here. At this point, simple linear equation. I'm going to bring it over here. 6x minus 10 equals 32. Adding 10 to both sides has the effect of canceling the 10 off of the left-hand side and putting a 42 on the right-hand side. And then as I divide by 6 here, that has the effect of canceling the 6 off of the left-hand side and leaving me with 7 on the right-hand side. Now, before I put a box around this as my answer, I need to do step 5. Check your solution against the domain. So I ask myself, is 7 one of these things that I was not allowed to have? And the answer is no, it's neither negative 5 or positive 5. And so that means that 7 is a totally fine solution. I'm going to put a box around it and put it into Pearson. Okay, let me clean up the board. Okay, so I've cleaned up the board, and there's 2 more examples here. Rational equations, they all sort of work the exact same way as the 2 that we did to begin with. The only difference is, do I get a linear equation that I have to solve, or do I get a quadratic equation that I have to solve? So the first 2 examples are what I would consider easy, because all of you at this point have taken your Unit 1 test, and so you know that you're good at solving linear equations at this point. Quadratic equations, I would suggest that if you're rusty on this, watch this video for the video check. Go back and watch the videos for quadratic equations, then come back and try to solve this once you're sure that you're good to go with quadratics. There's nothing different about the way that we solve this, except that we have to use the quadratic techniques once I've cleaned this thing up. So, first things first, I'm always going to note the domain. What am I not allowed to have? This one's pretty easy. If I plug in 0 into 0 squared, that's 3 divided by 0. Can't have that. If I plug 0 in here, same story. 5 divided by 0, you can't have that. So that's the only number that I'm not allowed to have is 0. I can plug anything else in. Okay, next step, clear the fraction. So I'm going to pick one of them, either x or x squared. I'm going to pick whichever one looks more complicated. I think x squared does. And I'm going to multiply everything by it. So when the denominator and the term I'm multiplying by match, they cancel, leaving me with the numerator. 5x squared over x. I'm going to write this one out, because what you'll notice is that the x on bottom cancels one of the x's on top, leaving me with just 5x, and I'll rewrite that in just a second. And then here I'll have 2x squared. So all together I have 3 equals 5x plus 2x squared. From earlier this unit, section 1.4, we know that we would like this to be in standard form. That means everything on the left-hand side in descending order equal to 0. And by descending order, I mean the exponents are in descending order, not the fact that this is a 5 and then a 2. We want them in descending exponential order. So if I rewrite that, I'm going to do that very quickly. I just need to subtract a 3 over to the right-hand side, then I can flip it and rearrange some things, and I'll be able to write 2x squared plus 5x minus 3 equals 0. Many, many, many different ways that we can choose to solve this. I'm going to solve by symmetry again. If you want to do by factoring, you can factor this one pretty easy. You can use your quadratic formula pretty easy. I'm going to do this by symmetry. So in symmetry, I need to divide everything by 2. Like this, equals 0. I'm going to write the answer down. That's half a negative version of half of this. So that's negative 5 over 4 plus minus that u term. And remember that this, we have a shortcut for, where we're going to use a difference of squares here to get our equation that we use to solve for what u is. So I will have 25 over 16, because that's 5 squared and 4 squared, 25 over 16, minus u squared is equal to, then I have to write whatever this constant term was, negative 3 halves. Now I'm going to do this, but I'm going to write negative 3 halves as 16ths, just to make my life a little bit easier. So if I multiply the bottom by 8, that'll turn it into 16. I also would have to multiply the top by 8. 8 times 3 is 24. So I have 25 sixteenths and negative 24 sixteenths. I need to rearrange this to get the u by itself. If I add u over and then add the 24 sixteenths over, that will give me 49 sixteenths is u. If I take a square root of this, then I can very clearly see that u is equal to 7 over 4, because that's the square root of 49 and the square root of 16, 7 and 4. Okay, so my answers to this are negative 5 fourths plus 7 fourths, which will give me positive 2 fourths, or in other words, x is a half. And then negative 5 fourths minus 7 fourths will give me negative 12 fourths, which is the same thing as negative 3. Okay, so I've gone ahead and put a box around this, and you can see that when I do my step 5, this is a very, very quick check. 1/2 is not 0 and negative 3 is not 0, so both of these are solutions to my equation, and I'm ready to go. If you factored it, you can double check to make sure that what you get is the same thing. And if you wanted to do quadratic formula, then you should have arrived at 1/2 and negative 3. Okay, last little note for section 1.6. Sometimes we get these extra types of equations like this. This kind of thing is called a radical equation. It's radical because it has a radical symbol in it with a variable inside of it. Okay? Just because it has a square root of a number does not make it a radical equation. But if you have a square root of a variable, like this one does, the square root of 4x plus 12, that makes it a radical equation. The way you solve this is pretty simple. It doesn't follow this exact sequence of steps, so I'm going to show you this one example, and then we'll talk about this additionally in class, but I encourage you to just go back and watch this many, many times, because they all are kind of the same thing. What I'm going to do is I'm going to pretend for a second, put a little pink box around this, I'm going to pretend for a second that this said just x minus something, like x minus 5. And if it was just x minus 5, you would know how to solve it. You would add the 5 over to the other side, and then it would say x is equal to 5. Okay? So we're going to do that step, although it's not going to immediately give us our solution. If I add square root of 4x plus 12 over to the right-hand side, then I will have x equals to square root of 4x plus 12. Okay? Once you have the square root symbol by itself on either of the two sides, it doesn't matter which, the move here is that you're going to square both sides, because squaring a square root, those are inverse operations, they have the effect of canceling each other. All right, when I square the left-hand side, I get x squared. Remember, we are squaring both sides. When I square the right-hand side, the power of 2 has the effect of canceling the radical, giving me 4x plus 12. This is a quadratic equation, and then we know how to solve these. I'm going to attempt to solve this one by factoring, because this one's nice and easy to do by factoring. So I'm first going to try to write this thing as a standard form quadratic equation. I need to both subtract 4x over to the left-hand side and subtract 12 over. So I'll write that in. Minus 4x minus 12 to both sides will give me x squared minus 4x minus 12 equals 0. That is a standard form quadratic, so if you want to use your quadratic formula, you can do that. If you want to graph this one's actually doable by graphing. And We can also do symmetry or other things that we know how to do in order to solve this one. I'm going to factor it. Factoring, I'd like two binomials that multiply to make this expression. I write the first term without the index in both positions. I'm going to multiply the leading coefficient, understood to be 1, by the constant. That's 1 times 12. So I'll have 12 and 1, 6 and 2, 4 and 3. We'd like to make the middle number by either adding or subtracting those pairs. 12 minus 1 can't make 4. 6 minus 2 can, so that means 4 minus 3 doesn't. So one of these numbers is a 6, the other one is a 2. To make negative 4 with a 6 and a 2, I could take positive 2 and subtract 6 from it. And now I have my two cases, either x minus 6 equals 0 or x plus 2 equals 0, which informs me that my solution set is x is either 6 or negative 2, and I'm done. Okay. Now, domain with radicals is a little bit harder, I find, for students to understand than with the rationals, because the rationals is pretty easy to see what you're going to plug in that's going to make it 0. With this kind of expression, we also have to be careful that we don't get complex numbers out of it, and that's a little hard for people to understand at first. So the way that I suggest that you tell if your answer is correct or not is you take both of these numbers one at a time and you plug them into the original equation and see if it's true. Okay, so putting a 6 here, let's worry about what's in the pink box. 4 times 6 is 24. 24 plus 12 is 36. The square root of 36 is 6. So if 6 minus what ends up being 6 is 0, then that's part of our answer. So I know that 6 works. I'm also going to do the same thing with negative 2. Okay, so 4 times negative 2 is negative 8. Negative 8 plus 12 is 4. The square root of 4 is 2. So negative 2 minus 2 does not equal 0. So I know that I need to omit negative 2 from my solution set. So my answer is just 6 in this case. And as we get a little bit further into these, we will start actually doing something that's very similar to these steps that I have written over here. We'll note the domain. Instead of clearing the fraction, we'll clear the radical, and then we'll use Unit 1 or Unit 2 skills in order to come up with it and check our solution against the domain. But until we have time to cover that, I would suggest that you follow the steps, get the answers that come out, and then plug both of them back into the original expression to make sure that it says something true. It's supposed to equal 0, so when I plug 6 in, I do get 0. But when I plug negative 2 in, I don't get 0, so I know that negative 2 is not one of my answers. If you can do those things, you've got section 1.6.